All right, so we've been working on arithmetic sequences and geometric sequences. And I know there's been, some confusion, and this can be kind of difficult when you look at all these formulas. Sometimes it can just look like it's too much. And I'm not going to necessarily dive into this and re-explain everything, but I did want to work out some problems. And so for right now, there's some things, like I said, I'm not going to dive into, but I'll touch on that. This is the explicit formula. The explicit formula is the main formula that we use. Of course, this is for arithmetic sequences. A1 is going to be our first term. D is the difference between the terms. N is the number of term that we're looking for, which we typically can find if we have a sub a term right here, then that'll be the number we put there. This is the term we're looking for. The recursive formula is a formula we won't necessarily use that much, and we will have to create the formula, but the most important thing about this formula is just the fact that what comes at the end is going to be our difference. So when we're looking at this, that's really the most important thing, and when we do our final questions with this video, you'll kind of see where that importance comes in. And then the same thing with these, except for R is ratio, which is what we're multiplying or dividing by. And then whenever you do this n minus 1, that needs to be an exponent. So that's kind of the big thing right there, is that will be an exponent. All right, so what we're going to do is we're going to look at, first off, take a look at two questions. And it doesn't tell you if these are arithmetic or geometric. And using what we have here, we're going to try to figure out which one's arithmetic and which one's geometric. So if you take a look at this, the thing that stands out to me is this R right here. And R is a geometric sequence thing. Here we have D. R means ratio, by the way. D, which means difference, is an arithmetic. Okay, which arithmetic is going to be your addition and subtraction. Geometric is going to be your multiplying and dividing. So just so that this doesn't confuse anyone, I'm going to switch these so that the geometric one is across from its formulas and the arithmetic is across from its. All right, so when you look at all this, there's a lot of different things going on here. And I know that it can be very overwhelming, but this is something that you can do, especially once you understand what it's asking for. So the first thing we're going to look at is the explicit formula. So we're going to look at this right here. So it's already kind of given to us, but we're going to plug in the things we know. And so they've given us a sub 1, and they've given us D. So I'm going to take my formula right here, go a sub n equals, and then my a1, I'm just going to plug in the a1 that they gave to me. So we got negative 37, and then plus 10. If this was a negative, you could either put plus a negative 10 or minus 10, either way. And then we have n minus 1. They have not told us n as of right now. So we're just creating our formula. So we're not, until I have a number right here, then we don't put a number right here. All we're doing is putting the formula. The recursive formula, the only thing we can replace in this, if you remember, I was saying the most important part of this is at the end, in which case we're looking for the D. So on this one, we're going to go a sub n equals, and then we go a sub n minus 1, and then that equals, The cat just came in. So this was plus 10. So plus 10 because we were putting D and D is 10. All right, so you created this explicit formula. You created the recursive formula, and all you had to do was to fill in just those numbers right there. So the A1, the D, and that D right there. Okay? So don't overcomplicate things when you're doing this. We're looking at the formulas that are already given to us. And then we're just plugging in the information we have. All right, so now we're going to use this information to help us fill out this table first off. This is going to be our sequence, but it's going vertically. And so I look at this and it says, okay, this is my first term. Well, what's my first term? Well, that's what A sub 1 is. So my first term is negative 37. Okay, negative 37. Then I got to find my second term. Well, here's where that D comes in. So when we look at this, if the difference is 10, then we're going to go up 10. Now, I would suggest you use a calculator here. Negative 37 plus 10 would be negative 27. There are a lot of kids that want to make it negative 47, so use the calculator. And then we're going to keep adding 10 and creating our pattern. So this would be negative 17, negative 7. Now right here, as I make this last one, make sure you use the calculator. Negative 7 plus 10 is not a positive 7. It's a positive 3. Okay? And so creating this right here, all we're doing is going through and we're adding 10. Okay? Or looking at this, doesn't matter, it's the same thing. We're adding 10 to all of these, just creating our pattern. Okay? Now that we have the pattern, the last thing that they've asked me to do is to find this A sub 27. So I'm gonna find my A sub 27, and I'm gonna use my formula, the same formula we came up here, but now I know that this N is 27. So when I do this, then I will put 27 minus 1. And we'll definitely want to use the calculator for this. So I'm going to switch over on our calculator. We're just going to basic calculator. And then I don't plug in this A sub 27 equals. Okay, that's just the name of this particular term that we're trying to find. So we'll plug in negative 37, negative 37 plus 10. Parentheses 27 minus 1. Close your parentheses, hit enter, and we got 223. So there's a lot of different things that they're asking us to do, and the reason why I think this is going to be a good video is because it's going to hit a bunch of different ways that you could see this. It's going to have you do a whole bunch of different things. So we're having the formulas. We filled out, completed a table, which we used our sequence in. We had to find A sub 27 using the explicit formula. And typically when we're looking for this, we will use the explicit formula. Okay? All right, so now this one, because it has an R, is going to be the geometric, okay, because it has that R. So D is the arithmetic and R is going to be the geometric. So once again, I'm going to create my formula just using what I see here. I'm just filling in what I know. So I'm going to go A sub N equals A1 is negative 4. So I'm plugging it in right there. Times R is going to be 6. And then right now I don't know N, so we just leave this as N minus 1. The recursive formula, all we have to do, once again, the only thing that really matters in this recursive formula is going to be this r at the end. That's the most important thing. So a sub n equals a n minus 1 times, and then what was r? R was 6. That's my recursive formula. So if I come over here, we're going to start with my first term. So first term is that a sub 1, so negative 4, and we're going to create our pattern, our sequence. And we're multiplying by 6. So negative 4 times 6 is negative 24. 24 times 6 is a negative 144. 144 times 6. We will go to our handy dandy calculator. 144 times 6 is 684, negative 864. And then I don't have to retype this, I just need to hit times 6, and it brings up my previous answer. And that's negative 5,184. Okay, so we filled this out. So now they want us to find the last thing, a sub 9. So we will use the same formula we came up with, except for this time, I know what n is. That's 9. So I'm going to go 9 minus 1. And then we'll plug this part into the calculator. So we'll go negative 4 times 6, and then I know you can barely see this because of this thing right here, but I'm hitting that house top, and then that's going to allow me to plug in my 9 minus 1, and then get the feeling I forgot to put in a parenthesis right there because it looks a little grayish. Put that there. Alright, so we hit enter, and gives me this huge number, but that actually is my answer. So negative 6,718,464. 6,718,000. Got the last part. 464. Okay, so it's kind of a big number, but that's okay because the calculator did it up. Okay, so this is one of the ways that we might see these sequences and what we did with it. Okay, this is another way we might see it. So here they actually give me the sequence. Now, once again, I'm trying to figure out, is this arithmetic? Is this going up by adding? Or is it geometric? Is it going up by multiplication? What about this one? Is it going, in this case, down with subtraction? So adding and subtracting would be arithmetic. And so in the end, you can kind of see this R, and it gives it away that this one is geometric and this one is. I'm going to reverse these two real quick. Okay, so I know this one's arithmetic because it's got the D. Also, it's going up by, or in this case, it's going down by 7. So I know that's from there to there is going down by 7. Down by 7. This becomes my difference. That's negative 7 right there. That's what we mean by the difference. Okay. A sub 1 is going to be my very first term. So whatever number is listed first, that's my first term. Now, this looks almost exactly like what we were given before, except we had to find it this time. So now we'll go find our explicit formula. So we'll go A sub n equals my A1, which is 39, plus negative 7 is D. You could put minus 7 there, same thing. Parentheses n minus 1. So that's my explicit formula. My recursive, once again, the only thing we care about is that D d at the end. So we got a sub n equals a sub n minus 1. And then d is minus 7 or plus a negative 7, either way. And then in this one, I didn't need to fill out a table or find my sequence. It's already right there. It wants me to find a of 25. So I don't have much room to write this. So I'm just going to go straight calculator here. I'm going to plug all this in. Remember, anytime we have this right here, we're going to want to use that explicit formula. So we're going to plug this in, but now I know n is 25. So I'm going to go 39 plus negative 7 parentheses, and then I know my n is 25 minus 1. Once I plug that in, just hit enter, we got a negative 129. So negative 129. Okay, so now we're going to take a look at this one. So this one, we notice the R kind of helped us out a little bit. So we know this is pattern's got to be something with multiplying. So we look at this, and it looks like if I multiply this by 2, I get negative 4. Multiply that by 2, I'd get negative 8. And of course, the pattern continues. This is my ratio. This is what we multiply and divide by. So that becomes my R, is 2. My A1 is the very first term. So this right here would be negative 2. All right, once again, I'm given the same information that I have been previously. Let's plug this in. So A sub n equals A1 is negative 2. Negative 2. All right, this thing's not like it. Times R, which is 2. And then parentheses n minus 1. Once again, we don't know that n yet. So we just write that. Recursive, the only thing that matters is that R. So we have a n minus 1 times R, which was 2. All right, last part here. This problem is we're just going to plug this in. So I want a sub 10, so the 10 is going to go in for the n. And we'll go negative 2 times 2. Hit that house top right there. That gives me my exponent. In parentheses, n is 10 minus 1. Once you have that typed in, our answer is going to be a negative 1024. 1024. All right, so there's one other way. I'm sure there's lots of other ways that we could see it, but one other way we're going to look at today. They haven't given us much information here. I know my first term is 32, but then they give me this right here. So right now, I may not even be sure if this is arithmetic or geometric, but I see this n minus 1, and I know this is the recursive formula. And if you remember, the thing we always talked about on the recursive formula is the very end. This is what tells us everything. And so when I see minus 2, that's got to be arithmetic, because we're adding and subtracting with arithmetic. You can see down here that this is multiplication, so that's going to be geometric. Okay? But in this, the main thing I need from this right here is that D is equal to, almost did R there, didn't I? D is equal to negative 2. That's really what I need from that right there. Don't let the recursive formula keep you from doing everything else. Once you get that negative 2, we have the same information kind of that we've had, and we can create our explicit formula. Or we can even just start our pattern. It tells us we want to find the fifth term. So when I do this, I'll do explicit formula first. I know I'm looking for 5. So we got our first term is 32. And D is going to be minus 2. Parentheses, and I know I'm looking for 5, minus 1. I'm just plugging all this into our explicit formula right here. And we'll go use our calculator. So we'll go 32 minus 2, parentheses, maybe, there we go, 5 minus 1, close parentheses, enter, and we get 24. Okay, now there's something else that you can do. So if you struggle with this right here, remember, we're talking about patterns. And this is the difference between all my terms. So if a sub 1 is my first term, so 32, funky looking tree right there, 32 is my first term. If the difference is negative 2, that means I'm going to go down 2. So that would put me at 30. And if I continue the pattern, 28, 26, 24, we were looking for the fifth term. 1, 2, 3, 4, 5. You can see either way, I get 24. So you can use this to make a pattern and find your answer, or you can put it in the explicit formula and find your answer. Either way is going to work. Okay, so now let's take a look at this one. All right, so this one looks really, really weird. And first off, I know that this is geometric, and I know that my R here is this 1/3. Now, first off, we can say R is equal to 1/3, and we just multiply everything by 1/3. I will take a second to say that a fraction bar just means division. So really, this is talking about dividing by 3. And so whether you're dividing by 3 or whether you're multiplying by 1/3, either way, you're going to be fine. And you might say, oh man, I don't think I could do this because I'm not very good with fractions. Well, that's when we have our calculator. So first off, let's go ahead and do our explicit formula. So let's go, we're looking for a sub 4. So A1 is 243 times, and then our R is going to be 1/3. And then I'm probably going to want to put some parentheses right here. Not sure how the calculator will handle the fraction, so I'll probably keep some parentheses around that. And then we'll do our n minus 1, and n is going to be 4, so 4 minus 1. I was thinking 4 minus 1 is 3, which you can do, by the way. But I like just making it look exactly like that. So we go to our calculator, and we'll type in 243 times, and like I said, I'm going to go ahead and put my fraction in parentheses just to make sure that the calculator handles it well. And then we hit our house top, and I'm going to go, I like to put these in parentheses too, even though I didn't write it down. 4 minus 1, close parentheses, enter, and you can see I get an answer of 9. So what if I wanted to do the pattern? So 243 is my first term. So you use your calculator. 243 times, and then we do our fraction. 1/3, 1/3. Oh, I guess that helps if I hit the 1. Okay, and just let the calculator do all that work. Enter. It's 81. Okay, and remember, I don't have to hit 81. I can just hit times, fraction, 1/3, enter, 27. And you remember that we were saying that this is the same as dividing by 3, so you might be seeing that. But like I said, if you don't, just keep multiplying by 1/3. And this is our fourth one. We got 9. 1, 2, 3, 4. 9's our answer. Okay, I know sequences, they really look tough, and but once you kind of figure out what everything means and you look at what's been given to you and take that and then apply it to our formulas and apply it to what we know about sequences, then you're going to be able to solve sequences. I hope this helps.